Our next presenter is Phil Nash. So, who had heard of Phil Nash before? Come on. So, how many of you have ever written unit tests? That was easy. Okay. How many of you have used Catch 2? So, you should know Phil Nash. How many of you have ever heard CPP cast? You should. Okay, so Phil is going to talk about tests. What else? What could he do? So I just leave you with Phil. Phil, thank you very much for coming.
Thank you. Okay, so let's get started with rewiring your brain with test-driven thinking. So we're going to talk a bit about test-driven development, but we're going to talk more generally about test-driven thinking. And the rewiring your brain part is really touching on a part that I don't think really gets talked about in this context usually, which is more the, we usually talk about the philosophy of TDD, but I want to talk about the psychology of TDD and maybe even the neuroscience, and why that's important as well. So if you have heard of me before, you know that I'm the original author of Catch, now Catch 2, but also have been doing a training in TDD over the last few years. And as of a few weeks ago, I'm now fully independent. So if you need TDD training, if you like this material, do let me know. So that's Reshape XR, that's my own company. Another thing that I've been interested in over many years now is, I suppose, the psychology of productivity. So things that can make us more productive, mental hacks, that sort of thing. A lot of those ideas have become a bit more mainstream in the intervening years, so I don't talk about them as much as I used to. A lot of people know what they are. But what I found just recently, with the last few years, particularly as I've been doing my TDD training, is that the combination of some of these sort of mental techniques, psychology, understandings, combined with how we practice TDD, actually go together to form even more than the sum of their parts. That's the bit that I really wanted to capture in this talk. So let's start with the absolute basics, talking about tests and why do we write tests? And before I get to that, I want to go back even more and say, do we write tests? So who here would say that they sort of regularly, as part of their normal everyday development, write tests? Not necessarily 100% of the time, but fairly regularly. So that's maybe a third, maybe a little bit less. So that's normal. All right, but who here would say that they know that they should write more tests? Right, a lot more. Not quite 100%, but the majority. Right, that's normal. That's normal. So why do we write tests? Or maybe let's flip that around. Since we said many people don't write tests, or most people not enough tests. Why is that? If we know that we should write more, what's stopping us? Well, there's a few reasons that people often give. I'm not going to go through them all exhaustively here, but here's just a few that I've picked out that are usually among the top reasons that people give for not writing tests. Perhaps number one is it's just extra work. You've written some code, you know it works somehow, and we'll leave aside whether that constitutes a test or not. But now you've got to write some code to verify the same thing again. Well, that's extra work, isn't it? And if it's extra work, that's going to slow you down. Makes sense. But perhaps more importantly, it distracts you from what you're doing. If you're working on this complex problem over here that you've got your mind right into, but now you've got to switch to a different task, which is writing tests. So that's going to slow you down even more, distract you, going to lose what it is you've got in your head. And for a lot of people, writing test code is it's not that interesting, it's boring. Not really what motivates them. So there are many more reasons, but perhaps some of these resonate with you. Now we're going to come back to this list. I'm going to set it aside for the moment. Come back to this question. And now finally ask the whole thing. Why do we write tests? Given that set of reasons for not writing tests, which is given, why do we actually write tests in the first place? So this part is more the philosophy of TDD. And again, I'm going to put up a few benefits from writing tests, by no means exhaustive. But perhaps the most obvious one is that we want to catch bugs. Yeah, that probably resonates with most of us. We write a test to catch a bug. And that's an important use case, certainly not the only one, and perhaps not the most important one, especially in the context of TDD. So that's interesting, but it's certainly there. How about this one? To encode our expectations. Maybe you hadn't thought of it this way, but what you're doing is you're thinking, especially if you're doing TDD, you're writing the test first, you're thinking ahead of time, what is it that I actually want my code to do? And then you're writing that down in code to tell you when you've done it. You're encoding that expectation. Now that turns out to be really important, perhaps more than you might realize, and we're going to definitely come back to that one. Let's try another one. To catch regressions, very similar to catching bugs, but maybe you found a bug and you want to make sure that bug never comes back, so you write a test for it, ideally before you even write the fix, so it's going to tell you when you fixed it. But even if the bug never existed, you want to make sure that as you're writing new code over here for something else, you don't break existing functionality. That's still a regression test. So that's slightly different, also very important, but also not the only reason. Or how about this one? And this usually sort of divides people into two camps. Those who think that what's documentation got to do with tests? And those who think, of course, the tests are documentation for how the code should be used. Maybe you've heard somebody say, oh, if you want to know how that works, go and have a look at the tests. I'll show you how to use it. Which is great, because unlike pretty much any other form of documentation, it can't really get out of sync. Because if it does, the tests break, and then you go and fix it. So it's effectively tested documentation as well. But there is a flip side. It is a double-edged sword, because you'll often write tests that probe at parts of your code you don't actually want people to touch, not in those sort of ways. So you're just writing the tests to make sure it doesn't break down under those circumstances, but that's not really how you want people to use it. So if you're going to use tests as documentation, then make sure you clearly mark which form it is. Is this how you want people to use it, or is it just how you don't want them to break it? Now, there's many more. This is still not exhaustive. In my training, I get people to come up and write up their own reasons, and I've been collecting this list over time. But here's just a few more. I'm not going to go through them one by one. What I want to point out here is that in this sort of cloud of benefits from tests, all the ones on the left-hand side you can get from pretty much any form of testing. Some more than others, but they're not really exclusive. The ones on the right-hand side, though, you only really get if you're doing TDD, which sort of explains why some of them might seem a bit odd, maybe not the way you're used to thinking. And we're going to come back to all of these on the right-hand side as we go through this. So hopefully by the end, this will be clear. Again, there are more, which means if you're doing TDD, or rather, if you're not doing TDD, you're missing out on some additional benefits. Before we get to that, let's come back to this list. These were the reasons we said, some of the reasons, why people don't write tests. Yes, a little bit of a spoiler, but just to see where we're going. What if I said to you that instead of extra work, tests could help you to avoid rework, such that in the long run, you're actually doing less work overall? And we'll come into how later. And what if I said, instead of slowing you down, tests could actually speed you up? And what if I said, instead of distracting you from what you're doing, they could actually keep you focused on what matters at any particular time? And what if I said, instead of tests being boring, they could actually be fun? Seriously. The big question, though, of course, is how can we deal with these things? How can we get these benefits? They're not the obvious ones. Well, that's what this talk, hopefully, is going to be about. And it really gets to that sort of underlying neuroscience and psychology. And I'm going to skip this video because people have told me it's distracting. But really it's meant to drive home one point, which is all of the principles of neuroscience and psychology I'm going to talk about, they're all underpinned by one thing, which I'm sure you're familiar with, that our brains, our human brains, are really just big association machines. Big network of interconnections, and it's those connections and pathways that give us the ability to do pretty much anything. It's not just about memory, but it's about moods and mental resources and how we can actually apply ourselves to things. It's all to do with these connections, and we're going to really drill into that in 3 ways, which I'm going to come back to a bit later. I'm just going to list them for now. First one's going to be about habit forming. And this is not really specific to testing or TDD. It's a general principle of psychology that if you haven't really looked into this before, you can benefit from. But we're going to apply it specifically to TDD, because even if I've convinced you that TDD is the right way to approach coding, and you learn it all and you think, right, I'm going to wake up as if we're in the Matrix and say, I know TDD. And then you go out with the best of intentions and day-to-day life gets on top of you and you're back to your old habits. Habits are really strong. So understanding how to alter them and master them is really important to this. And it turns out there's a link onto the other points as well, particularly the second one, which I call dopamine triggers. And we'll look at what that is all about when we get to it. And the third one is all about externalizing your brain. So that's the little spoiler. But I'm going to take a little bit of a detour to get there, because I'm going to talk about 2 cycles. Not these ones. This is a picture of my sons, actually about 10 years ago now. They're a bit bigger and so are their bikes. But there are 2 cycles up there. But no, the 2 cycles I'm going to talk about. Well, the first one is the TDD cycle. So if you've looked at TDD before at all, you're probably familiar with this. But want to make sure that we're all on the same page. It's not going to be an in-depth introduction to TDD, but I want to try and get everybody on the same page. So we have these, there's 3 main components here, sometimes called the red-green refactor cycle, after the colours. I've added a couple of extra bits in as well. So we always start by writing a failing test. Now, if we don't start with a failing test, it's not TDD. That doesn't mean it's wrong. There's perfectly valid approaches to testing, which involve you starting with a test that passes first time, but it's not part of the TDD cycle. It's important to distinguish. And we want to, as we're doing TDD, we want to maximize the number of failing tests we can write first. And that's a real art. TDD itself, the process here, is really simple. I can explain it on one side. I'm doing it right now. But mastering the art is the harder part. And that's one of them. And I'll touch on that a little bit soon. So once we've got our failing test, which might actually be the compiler not able to compile the code because you've written a call that doesn't exist yet, or referred to a type that doesn't exist yet, for example, that counts as a failing test. It's just that your compiler is the test framework. Or it could be a test in a test framework. It could be lots of different things. Test-driven thinking is about applying this approach at more general levels as well. But once we've got our failing test, we've encoded our expectation in the test, remember? Then we can move on to the green step, where we make the test pass. But importantly, we write just the code to make the test pass. And this is another subtle, tricky bit. It's easy to think, well, we're doing TDD because we want better quality code, so we spend longer writing better quality code at this step. But no, here we write the simplest thing to make it work, get the test green, passing, hence the colour, because we have a separate stage, the refactor stage, which is all about changing the structure of the code to be better factored, apply good design principles. That's where this magic happens. But while the tests were already passing. So now if they break, we know it's because of what we just done, and we can fix it easily. And if we do make big changes in the refactor step, we can easily get back to a fully working state at any time. So we separate those things out. And the trick there is that often we'll get to the refactor step and think, no, there's nothing to do here. I'll put it off for this time, which you can do, that's fine. And then you do it again the next time. And after a while, you forget to do it at all. But if you do that, then all you're doing is you're just hacking code. and you won't have a good design at the end of it. So it is important to keep the refactoring step in mind. And then once you've done that, all your tests are green again. That's also important. Then we get to ask this question: are we done? Is there another requirement to meet, or is there another test to write? Or are we actually done? And it might seem trivial, why do I even put it on here? It's not usually part of the cycle. We're going to come back to that later and see why that's important to put it there. That's it for now. I'm going to just do a little worked example just to draw that home. Again, within the time constraints, not going to go into too much depth. So if this doesn't convince you, don't worry, it's not the end of it. But the example I want to do is left pad. Who remembers the incident a few years ago now where the JavaScript library to left pad got pulled because of some argument by with the author of it, pulled from NPM, and then half the internet stopped working because it turned out that they all transitively depended on this tiny little library. And part of the discussion about that was, why does half the internet depend on this really simple library that anyone could write themselves? Well, let's do that in C++, of course. So, of course, we're going to use catch. So if you've not seen catch or catch2 before, this is it. Header only, or at least it used to be. This is the classic version. So actually, if we just include it like that, okay, we have to do something somewhere else, but we'll brush it under the carpet. Then that's a complete program. Doesn't do anything. But this actually does start to demonstrate the principle of test-driven thinking. You always want to see your baseline before you do the next step. You want to maximize the baby steps. It's really the principle. So it's good to see that when everything else is working. And then we can write some code and see what that does. Just an empty test case. Again, we know where we are, what our baseline is. So let's write a test. We wanted a function called leftPad that takes a string and I call it min-len, the minimum length of the string at the end of this. And then that's going to return a string. So we can write that call there. We haven't written the function yet. That's fine. Notice the values here. I've just gone for the simplest possible values, empty strings, zeros, and so on. And that's a key principle. We always want to start with the simplest and work our way up gradually. Okay, now, of course, that doesn't compile. That's a failing test. So these days, we don't even need to try to compile. If we're using an IDE, chances are it's going to highlight code that doesn't compile yet for us anyway. This counts. This is a failing test. So let's make it pass. Write a function with that signature, return a dummy value. But there's a problem here. So the principle of starting with the simplest possible values applies to the code under test as well. So we've returned an empty string. But now it passes. And you might think, well, that's fine. We saw a failing test and now a passing test. But actually, there were two tests here. There was the compiler test, which we got to pass by writing the signature. And then there's a runtime test. And we haven't seen that fail yet. And we'll often get to this situation where we start with the simplest possible values and they match up. So we're going to have to make one of them incorrect. I know it seems counterintuitive, but bear with me. The question is which one? Do we change the test to be incorrect or the code under test to be incorrect? Now the clue is in the name test-driven development. We're driving our development or our design from tests. So the test should always be correct. We'll use that to evolve the design over time. So I always want to keep my test correct. So I'm going to change the code under test to be incorrect. Doesn't matter what you put there, as long as it fails. So now here's our runtime failure. And we can see we're getting some quite nice feedback. We can see what the results were, the left-hand side, the right-hand side of the expression. If you've not used catch before, it might seem surprising that we've got that much information. Use its expression templates under the hood. Feedback's really important in testing and TDD. Being able to see what it was that failed, really important. You always want to maximize that. Okay, change that back to what we had before, but now we know that this is passing exactly because of the code that we just wrote. So we get that confidence as well. Most of the time, that might be trivial, but how often have you written some code and thought, oh, that's all working, and then you realize you were testing the wrong thing? And those sort of problems can take hours, days sometimes to track down. This took seconds to do, even with me explaining it. Okay, so we have our first actually passing test. Another property of always seeing the test fail and then pass and starting with the simplest possible values is that it forces us to write the next test and the next test. We want to try and make that happen so that you can always write a failing test. So let's write the next simplest thing. So in this case, I'm going to use a non-empty string, but still keep the pad length to 0, one step at a time. Of course, that fails. So now we're going to transform our code under test from a hard-coded constant, the empty string, to the next level of genericity, which is going to be a variable in this case. Really just the string that we passed in. And that's enough to make it pass. We know we're not there yet. We're gradually evolving the complexity. Now, an interesting thing happened here. So previously we had the empty string. We had a test for that. Now we've still got the same number of lines of code, but we've got two tests. Now, who here uses code coverage tools? Handful of people, but I'm sure most people are familiar with them. They always work on line or statement coverage. Our line coverage hasn't changed, but our branch coverage has. We've increased the branch coverage at the important points, those points where things inflect from constants to variables, variables to conditionals, and so on. That's the secret here. Okay, well, we're not there yet. We have another test to write. This time, let's change the padding length or the minimum length, but we're now going to put the string back to 0, so we're just doing one thing at a time. So that's failing. So now we need to go to that next level of genericity, a conditional. So we'll introduce an if statement. Now the if branch, the first branch, is the original code, just returning the string. The else branch is our new code. So the same rule applies. We go back to the simplest possible thing, hard-coded string to match what we needed. And that passes. Of course, that's not good enough. Forces us to write the next test. So now it's just a slightly bigger padded string. So that's not enough. We now need to have a padded string length that depends on the argument passed in. Now I happen to know there is a constructor for std_string that takes a character and a number of repetitions, and we build a string from that. So if you're like me, you're going to write it like this, first time, which compiles usually with no warnings, but fails the test. Because actually the argument should be the other way around. They just happen to implicitly convert. So it's a tricky one, always catches me out. But we caught it straight away in the test. So we can fix the order, test passes. Great. Okay, but we haven't combined the two yet, the string and a pad length. So let's do that now. I'm going to use a slightly bigger string as well, just for a bit of variety. Of course that fails because we're only doing one or the other. But now we just need to make a small incremental change to our else branch. Instead of returning just the padding strings, we're going to reduce the length of that by the length of the string and add the string itself, like this. And that's it. That now works, passes all the tests. And the interesting thing here is that beyond this point, I struggle to think of any more tests I could write that will fail when I first write them. Which means that as far as TDD is concerned, we're done for writing tests. It might seem surprising, we have such a small number of tests here. That doesn't mean there are not more tests that we could write. And very often I'll write one or two extras around boundaries just to get a bit of extra confidence that I haven't gotten off by one error, that sort of thing. It's okay if some of them do pass first time. They're not part of the TDD cycle, but they're still part of the process. But beyond that, I wouldn't do more using these example-based tests. Because we've got all of the boundaries that we could think of. Now we're looking for boundaries we hadn't thought of, and we're looking at the whole range of strings and integers. We're never going to get there. So in my training, I usually then start talking about property-based testing as a really good approach for testing outside of these boundaries. There are other forms as well. That's beyond the scope of this talk. But the other thing we haven't done yet is refactoring. Hasn't been a lot to do. And sometimes it's, you can wait till this point. We think, well, I'm basically done with the tests. Let's go back and have a look if we can refactor. And you can see there's a bit of repetition in some of the code up there. We've got, the conversion to string a couple of times. We've got minlen and str.length appear a couple of times together. Let's dig into that a bit. So the first thing I want to do is look at that minlen minus str.length. What does that really mean? Let's give that a name. Something we often want to do, make our code clearer. So that's actually the pad length. So I'm going to do extract variable. It's one of the refactorings. Pull that out as a variable there. The code all the tests still pass. Always run our test after every change. It's great. Now that we've got that there, remember I said that minlen and str.length, they appear together two different ways. I wonder if there's a way that we can extract that out as well. One thing we could do is say, well, if we took the stud max of 0 or that minlen minus str.length, the pad length, then we actually get rid of the conditional as well. I mean, it's still there, it's sort of hidden inside stud max, but in our code, we don't have any conditionals. So I actually consider that an improvement. Well, except that this doesn't work. If you run that, it fails. And if you haven't spotted it, it's because we're dealing with all these unsigned integers, but we're subtracting numbers and it's going to go negative. You're going to end up with a big number, basically, and try to allocate a string that size. That's what's going wrong. And yeah, if you didn't spot it, this might be one of those rare cases where you still have to go into the debugger. You do that a lot less with TDD, but it still happens. And you'll very quickly find it. And you think, oh yeah, of course. And there's a couple of ways we could fix that. Strictly speaking, all you need to do is just do stud max of int. I'm going to change the argument as well, so it's a little bit more honest about it. But that now all works. All the tests pass again. Now it's debatable. You might differ with me on whether this is a better design than what we had before. But that's the point. You can experiment. You can change things in different ways. Knowing you can always go back to where you were very easily. And maybe performance is more of your priority here, in which case you might change it a different way. And that's fine as well. But you've got tests that are going to tell you when you go wrong. So that's a very quick whistle-wind tour of TDD. So as far as I'm going to go with that for the moment, because I've got more to get through. I mentioned 2 cycles. This was one. The other one is where we switch over to the psychology and the habit loop or the habit cycle. So maybe you've seen something like this before, but to understand a habit, you have to understand all of the variables. What we usually think of as a habit is what we call the behavior or routine part here, the thing you actually do habitually. But perhaps even more important are the cue and the reward. And very often, those things are hidden variables for us. We have to really dig to find them, maybe even do some experiments. In this case, I think they're reasonably straightforward when it comes to TDD. But just looking at the habit loop itself for a moment. The key here is that at some point, we got some reward, something that made us feel good, and we did that in response to a cue in a particular environment. So we did something in response to a particular cue. And that happened enough times that we built that association, that pathway, path of least resistance, that says, well, to get to the thing that I enjoyed before, I just follow that path. That's it. And once that happens enough, you don't even need the reward anymore. The path itself will take you there. That's why habits can be so hard to identify to begin with, and change even more so. You have to identify the cue and what the reward was at some point, even if it's not there now. So, what do I think they are in this case? Well, we're saying that when you want to write some code, then you want to write it with a test first. And perhaps previously, the behavior was you just hack away at code until it works, or you've got your own process for it. You have to examine that yourself. But whatever it was you're currently doing, in response to that cue, that's the thing we want to change. And the reward is, again, you'll have to examine this yourself, but I think very often it's that you get some immediate positive feedback. And it's especially true if we started out perhaps as a hobbyist programmer. I know many of us did, where we got into it because of, you write some code and then you see something work and you think, wow, that's amazing. And maybe that fades over time, but again, the habit's still there. So you may be more inclined to just sort of hack away at code. Now, interestingly, if we do TDD, you do get immediate positive feedback. We already talked about the test changing from red to green. Right? Might seem like a little thing, but lots of little things really add up. If you concentrate on the positive reward of seeing your test turn green, you get lots of those. As you've just seen, even for a simple thing like left pad, we went from red to green many, many times. See those all as wins. Right? That's your positive feedback. And that forms the reward in the habit loop. So even just focusing on that alone can be enough to start to shift the habit, build a new habit. In a moment, I'm going to give you an extra layer to maybe ratchet it up even further. But just to emphasize again, after a while you won't even need the reward. It just becomes a pure habit. And once it is a pure habit, this comes with a warning. Because as we all know from our experience with other habits, it's hard to not follow a habit. If you build a habit for TDD, you're going to find it difficult to write code without test-driven thinking. Now, I think that's a good thing, but just be warned. Now, consequence of that is one of the many objections I often hear to TDD that we didn't cover earlier is, oh, you can't do it with this type of code. It could be embedded or UI code or something very network oriented. Whatever it is, I'll often hear people say, oh, there's not really anything I can test, or it's just too difficult to. What I found is that if you start with that test-driven thinking, where you're almost addicted to TDD, you will look harder, and you will think, actually, I can bring more of this code into this area, and I can pull that here, and actually, there's quite a lot of code I can test, and you just push everything else back. Just that alone, I got very far in being able to test code that people think is untestable. So that's the warning. It's hard not to follow that habit. Let's talk about dopamine triggers. Now, I'm sure we're all familiar with dopamine. In fact, here's a Wikipedia quote. In popular culture and media, dopamine is often portrayed as the main chemical of pleasure. Oh, and another principle that I meant to mention before, the pain-pleasure principle. You may have heard of that too. So as animals, we instinctively move towards pleasure away from pain. Yeah, we can override that consciously, but it's hard. But that's our sort of default mode. So you can see how dopamine fits into that. But there's something a bit off here. Looking at this quote. It says, in popular culture and media, it's often portrayed as the main chemical of pleasure. Does that mean that it's not, actually? Well, there's a little bit more to this. So, reading on again from Wikipedia, it says, but the current opinion in pharmacology is that dopamine instead confers motivational salience. What does that mean? Well, the motivation I'm sure is understandable. In fact, the root in there, the motive part, implies motion. So that pain-pleasure principle, you can see how, we want to move towards pleasure, away from pain. That's motivational. What about salience? Well, if you're not familiar with that word specifically, I don't know how it translates, but you may be familiar with salient, as in the salient facts, maybe that expression, meaning the important or relevant facts. So in a particular situation, you want to identify the relevant facts. Well, this is saying, well, you are motivated to find the relevant facts. So dopamine actually gives you that motivation. It's basically priming you for learning. And they found this out through a series of experiments, and as these things often are done with trained monkeys, and we can argue the ethics of that, but they had this trained monkey in a room, of course, strapped up with all the sensors so they can measure dopamine levels. And it has a lever. If you pull the lever, you get a treat, probably a banana or something. And every time they pull the lever, they get the treat. And initially, dopamine levels would spike, and they'll keep pulling the lever. But after a while, the dopamine would tail off. And then they'll just stop pulling the lever, because they don't have bananas for now, and they knew that they could get that banana anytime they wanted, just by pulling the lever, because they'd identified the pattern. They'd found the salient facts. So dopamine was no longer necessary. So they did another experiment, where basically the same, but they only gave the banana 50% of the time at random. And what they found was the dopamine levels stayed high, because now the monkey's continually trying to find the pattern, motivated to keep trying, keep looking. All right, what's that got to do with TDD? Well, what things, as part of TDD, will give you a reward many times, but not all of the time? Actually, most of the things that we've looked at. What we just talked about, seeing a test pass, or seeing a test turn from red to green. Well, it happens most of the time, but not all of the time. As we saw in our worked example just now, we've got a couple of issues, unexpected issues crop up. And the great thing is, now with dopamine at play, we are primed for learning at exactly the point that we need to find out what the problem was. So it gives us that motivation. Also, that race to green stage, the green stage where we're just hacking at code rather than necessarily looking for a good design, it's introduced a bit of a fun element, which sort of plays into that, main chemical pleasure aspect. And even the cleaning code without breaking anything, the refactor step. For many of us, that could be quite motivating as well. So all of these things play into the role of dopamine. If we pay attention to them, then we can maximize the effects of dopamine, which actually maximizes our productivity with TDD as well. So it's an interesting thought. Okay. The third area to look at was externalizing your brain. So what am I talking about here? Well, this is all about, as humans, we are what we call open loop creatures, meaning that we thrive best with other people. In general, I know individuals may vary, but we've evolved to live with other people. And our communication and thinking styles take advantage of that. We think better with other people. And in time, we discovered that we can get a lot of the same benefits just by writing things down, because we can offload our thoughts, freeing up mental capacity to work on other things. And that turned out to be more productive. And of course, more modern times, same principle, but we can use technology. Turns out we can also do the same thing with TDD. So remember I said about writing a test is actually encoding your expectation. That is a form of offloading one thing you've had to think about into the code to free you up from having to worry about it. So you can go off and you can think of something else, take a different approach. And there's actually even more than that. Again, bring in this idea of the brain being a big association machine. Well, When you're writing a failing test, you have a requirements mindset. You're thinking about, what do I need the code to do as a user of this code? It's a very different role to implementing. But once you write that test, you not only offload the information, but also the whole mindset. It frees you up to switch into a different mindset. So you go from high-level design and requirements to that sort of race to green. Just implementing code. You don't have to worry about requirements because the test is doing that for you. So you can make that transition very quickly. And then similarly, going to the refactor step. Now, well, we don't have to worry about making the code work. It already works. The only thing we have to think about here is design. Good quality design, refactoring, all of those principles. Freed up from everything else. So we can play these three different roles and we can switch between them because we get these sort of save points provided by the TDD cycle. I think this is one of the most powerful parts of why TDD works. And most people are not talking about it, so I think it's a shame. It's also why I put the are we done step back over here, because really it's part of that requirements mindset. Once you're done with your refactoring, you transition back to requirements mindset, and there you ask the question, are we done? How often have you been down at the code face implementing away, and rather than thinking, what should I do next, you think, what can I do next? This would be cool, although this might be useful later. Well, this stops us from gold plating. We're thinking what's actually needed, the right mindset. Really powerful. That's externalizing your brain, which along with dopamine triggers and habit forming are what I think of as the psychology and neuroscience of TDD, which I think also answers some of these things. Hopefully you've seen how, if you believe all of what I've just said, it can keep you focused on what matters. That was the last bit, right? It doesn't happen overnight, but if you get practicing TDD, after a little while, you will be able to quickly move between those mental states and keep focused on one thing at a time. And also, particularly with the dopamine, it makes it fun. And I'd also throw in the hacking away part as well. Appeals to some people more than others. But what about the other two? Avoiding rework and speeding you up. You may have heard of shift left testing, or variations on it. I traced it back to this Dr. Dobbs article from 2001. The idea is that there are different stages of software development. And in fact, really this comes back even further to code complete. A table like this, you may have seen something like this, but the later you leave something in the software development lifecycle, the more expensive it is, both in terms of cost, but also time. And so the idea of shift left testing is to say that, well, if you're testing earlier, then the cost of bugs and rework is going to be much less. So really just following that principle alone, you can see that we're going to save time overall if we are testing earlier. But there's more. There's a question for you. Why do cars have brakes? Now, the fact that I'm asking you this question, you know there's a trick coming. But if not, the first thought for most people is, well, so you can stop or slow down. Seems natural. But actually it's the opposite, so you can go faster. Because how fast would you drive if you didn't have brakes? And this is a metaphor for tests. The tests are not there to slow you down. They're there to stop if there's a problem, so that you can go faster. You don't have to worry as much. You might have heard of the term, courage to make changes, because you know you've got a good suite of tests. This is how you can go faster, because the tests will catch you. They're playing that role for you. So I had to breeze through that bit a little bit more quickly, but that's how we tick off all of those. And that is how we rewire our brains with test-driven thinking in C++. And by the way, there's a load of references and things you can find on my website, levelofIndirection.com/refs/rewire.html. We're all there. Thank you very much.
Thank you very much, Phil. So, any question? I was waiting for you, Peter.
I'm sorry for not asking a question, but thank you to repeating stuff that I've been trying to teach for almost 20 years.
Well, thanks, Peter. That means a lot.
And it's depressing that it's still required to teach it that way.
Yeah.
So, and no more questions.
I think I can answer with a question to the audience. So, how many of you think that writing a lot of tests is necessary for your development? Okay, now the next question is, how many of you have had hard times trying to convince your management that you need to do more tests? So we need a different talk. We need a talk for managers.
Well, yes and no. It should be part of your development life cycle, so it's not a separate task to do. If you're having to do a separate task you need to get justification from management for, then you haven't done it soon enough, is my opinion. But I think Peter might have a...
Just don't tell the management that you
Right, yeah, don't tell them.
Okay, Peter.
In the worst case, it's easy to ask for forgiveness and permission.
Okay, let's leave the opportunity for somebody else.
So I believe in unit testing until you introduce mocks. Because when you start, lying to yourself, you have two things that can go wrong in different directions. And at some point, I think that integration testing is more useful than unit tests plus mocks. So what do you think about mocking?
I didn't catch the last bit. What do I think about?
So what do you think about mocking? How would you introduce, if you have to use mocks, how do you involve them in the cycle that you described?
Right. Yeah, that's a tricky one. It's not usually a unit test thing. It's more integration testing or system testing, which you also need. And you can even use those with TDD, but that's beyond the scope of today's talk. But yeah, unit tests have to be very deterministic and sort of line by line based, knowing exactly what's going on. As soon as you introduce threading, locking, anything like that, there's some limited types that you can do with unit testing, but in general you have to rely on higher level tests to get any sort of confidence in that. There's also approaches that take a lot of that out. Like I'm a big fan of using atomics with persistent data structures that can be made almost trivially lock-free. I mean, there may still be locks in there, but the way you reason about the code is the same in a deterministic environment versus in the real world. And then you can actually test stuff much more readily. But in general, yeah, there are types of problems that don't lend themselves very well to unit tests, but it doesn't mean they can't be tested. It's just you have to take a bigger view. That's probably another talk.
One more question.
Thank you for the presentation. I was wondering how strong of a role requirements play in this, or requirement gathering play in this development, because I've seen a lot of test-driven development, but the tests are kind of, they explain what it should do, but not why it should do it like that. And then when people have spent a lot of time writing tests, then they get demotivated because they have to make it do something totally different. They didn't set the requirements well. So they did do test-driven development, but just the requirements were not there.
Yeah, so don't get too hung up on the word requirements. That can mean different things in different contexts. If you have requirements given to you by a domain expert, everything must do these things, and you just got to go away and code it. Well, that's a very clear distinction then, and it still changes the role a bit, because you get put more in that driving seat of what's it like to use this code. You get more of a chance to question requirements than you might have done otherwise. Gives you those mental resources to say, I'm just thinking about requirements. Does this make sense? Do I need more information? But more often they're a bit more woolly than that, and often we're the ones creating the requirements. We may not even know when we start what those requirements are going to be, and that can still work. There's a big myth that TDD means no upfront design, which is not true. It can work with a lot of upfront design, but what it does push back on is that sort of complete upfront design that was very popular in the 90s, where we were writing UML diagrams and getting down to these class diagrams before we wrote a line of code, and that's never worked. And this just gives us a way to say, okay, you can think about the design up front. This is how we want it to all work, but also allow a bit of leeway that the facts on the ground, as you start writing things, you may think, oh, based on what I've done so far, that direction I had in mind or some other team had in mind, that's probably not going to work. Let's revisit that and go a different direction. And so there's an aspect of emergent design alongside the upfront design, and it's the two together that are going to give you a successful project. And this just allows you to move that slider as you need, by just putting you into that role of going back to thinking about requirements each time round the cycle.
Sure. One thing that I really like about PBB is that at the end, you end up with tests, right? And you can run them and they run automatically, and you can, refactor your code and whatever. But you have the test already there because that's the first step, right? How do you make your team go in that direction, like culture-wise?
So this is more about how do you get other people to do the same thing. Then, yeah. I think the number one thing is lead by example. So you need to show that you are not only doing testing, but you are achieving results because of it. And one of the things that I go into more in my training is that while it's not actually that hard to learn TDD, even some of these trickier bits, getting good at it, it's a skill that you have to work on. And initially your productivity is going to go down. So if you go out of this room and go into the office next week and say, right, I'm going to start doing TDD, that's probably not going to be the example you want people to see. So make sure you practice it sufficiently on your own or with other interested people till you get to the point you think, right, this is actually a better way of developing. And, almost I can't think of another way of doing it now. Then you start to show other people that, and that will have more of an effect. And people, not necessarily straight away, but they will start to ask, how are you doing this? And that's a really great way to get other people on board. In some cases, it becomes a top-down thing. Management says, this is the way we're going to do it. That's harder to make successful, but can be done as well. It's much better if it comes from a much more grassroots approach where you show that this is a better way and don't actually have to convince anybody. Or you just give talks. Thank you.